Yeah, live now.
Hi, guys. Thank you for joining our end of the year first workshop. I'm Eamon. I'm a full stack engineer here at Quest Network. And today we will be going through an introduction of Request Network. What is Request Network and how does it work? We will dive a bit into some payment networks and seeing the different payment networks that Request Network provides, as well as the different ways you can use Request Network to integrate with your project, such as the Request Network SDK. And at this point, we will dive a bit into writing some code and seeing some code and how it works. And then we're going to see some other tooling that we built for you guys to have faster integration, such as the request injector and the templates. So first, we need to understand what is Request Network and how it works. So in very few words, Request Network is a protocol built on top of blockchain to add context to blockchain payments, such as invoices and payments and like bills and receipts. And we call these requests. We also have a set of smart contracts that allow us to do reconciliation of payments with invoices, which we will dive a bit deeper into in a bit. To get a general overview of how it works, we have this graph here. And basically, when we're creating a request, we need to pass in the normal contextual data that we would see in invoices or payments, such as the payer, the payee, which currency are we denominating the invoice in, as well as the amount. And this contextual data is then written into IPFS. And once we get the IPFS, the hash from IPFS, we store it on chain on our smart contract. Each request is linked to a payment reference, and this payment reference is then used to pass into our smart contracts during payment in order to detect when a payment happens. So the way it works, you pass in the payment and make a transfer. The transfer goes through our smart contracts and an event is emitted. And this event is then indexed by our subgraphs. Once all of this is done and you try to fetch the request data from the protocol, both the IPFS data that is stored there, as well as the data that is indexed in the subgraph, are merged together and end up giving us the full request with the payment information, as well as the contextual data that we already added before. The benefits to this and using Request Network is number one, as I mentioned earlier, we would have automatic reconciliation of our invoices and payments. They are both linked, and whenever a payment happens, the invoice is set as paid, as well as data ownership. Since all requests are created by your wallet, your financial data is linked to you. This gets us to our next point, which is interoperability. All of your data is connected to your wallet, which means if you create a request from an app that uses request protocol, you can move into another app and make a payment from another app, since all of them can connect into the protocol and allow you to interact with each other. Also, it has speed in terms of integration as a protocol, as well as the speed of doing and creating requests and making payments. Next, we're going to talk a bit in theory in terms of the payment networks that Request Network provide. We're not going to go too much into details when it comes to these payment networks, at least most of them. We're going to keep that till tomorrow's session, which will go deeper into advanced topics. But in a general overview, Request Network can also provide conversion payments, which means that you can create a request that is denominated in US dollars, and at the time of payment, the equivalent amount in ETH is calculated, and the payer can pay in ETH. We also have swap payments, which is very similar to conversion payments, but on top of that, there is a swap that happens during the payment. So we have an invoice that is denominated in USD. the user pays in ETH, and the person who created the invoice gets paid in USDC, for example. We also have in-memory requests, which are very similar, as well as provide a different flow to normal requests, in a sense where in-memory requests are not directly persisted on chain, where this allows us to prioritize the payment first. This is very beneficial if we have an app that is more like an e-commerce, where the payment is the priority rather than the invoice. So in an e-commerce situation where instead of us creating an invoice and then someone else pays that said invoice in a couple of days, the payment happens at that exact moment, and then a receipt is created for the user. We will dive more into this in a bit when we're discussing the SDK, and we can see how that works in code. We also have transferable receivable. This allows us to turn a request into an NFT, which then allows the people to transfer NFT, and the request ownership is linked to that NFT. So this will be very beneficial in the instance, for example, of the invoice factoring, where person A can create an invoice and then sell the NFT at a price to person B, and then when the payment happens, goes automatically to person B since they are the owner of that NFT. We also have batch payments, as the name says, allows us to batch multiple payments of multiple requests at once, as well as our latest addition, the single request forwarder. As I explained earlier, when a payment goes through our smart contracts, an event is emitted, and that is how we detect payments. But that normally happens with a function call. With a single request forwarder, you get a unique smart contract address that you can make a normal transfer into it without having to do a function call, and that does the same as if you transfer and make a function call. Now, how can we use Request Network? There are three main ways to integrate and use Request Network in projects. First is the SDK. This allows full access to all Request Network functionality, and you can install our JavaScript SDKs into the project. And that way you would be able to use all of the functionality that Request Network provides, such as the functionalities that I mentioned earlier and more. We also have, this is like the SDK is the full range. It allows you the most liberty to do whatever you want with the SDK when you're integrating. We also have the request injector, which is a CLI tool that allows you to wrap pre-written and pre-built functionalities into your project. Instead of you having to install the SDK itself and write the functionality yourself, this allows you to have functionality that we wrote and is ready, and you can inject it to your project. But after it is injected, you are able to then modify it and change it to however need it fits to your project. And we also have, lastly, the web components, which are pre-built components that come with UI and functionality. These are very beneficial if you want to start very fast to add the features, but also limiting in the sense of it only comes with the feature and the UI that are already built into the components themselves. So you cannot extend them by default. So before we move on to request invoicing, I would like to go into some code. You are welcome to ask questions as I'm explaining the code. You are also very welcome to write the code along and try it yourself. I'm going to try to explain it step by step and go slowly. So if you have any questions and if you want more explanations, please do tell in the comments. So this is, we'll be using the SDK to go through a process of setting up the SDK and creating a request. Then we're going to pay a request, and we're going to try to also read a request by request ID and the wallet. And I'm going to also go and explain the flow of in-memory requests as well. So starting with our packages, here we have some already packages that I installed earlier, such as the request client.js. This package is the main package for creating requests. We also have the payment processor. As the name suggests, this is the package that deals with the payment of the requests. So, and we also have the EPK signature, and this allows us to use a private key in order to connect to our wallet, which we'll use for the signature. This is very specific right now since I'm using it in a backend environment. So I'm using the private variable, but on front end, you can use any wallet provider such as RainbowKit or anything in general. And you can use that to take the provider from the wallet provider and then use that for the signature. So you don't really need the private key. So our first step here is to set up the signer and use the client. As I mentioned right now, I'm using the Ethereum private key signature provider that takes in the private key from our environment variables. And we use that in our request network instance. So we're creating a new request instance. We need to pass in which gateway we're using. Currently, I'm passing in the Gnosis gateway, but in development as well as in the hackathon environment, I do suggest you use the Sepolia gateway. But I'm using the Gnosis gateway to show you later on with request scan. We also pass in the signature provider, which is the provider that is going to sign for the creation of the request. In our case, it's this one here that we created from the private key. In order to create a request, as I mentioned earlier, we need contextual data. So we need to create this object that takes in the necessary information for the request. For example, it takes in the request information such as currency. We have two types, which is either ERC20 or Ethereum. When we say Ethereum, we mean native currency. We also have the value. Here, it can be either ETH if we're using native tokens, or we can pass in the ERC20 token address. So if we change this to ERC20, we would need to here also change it to a valid ERC20 token address. And we also need to pass in the network of where we want to have the invoice and the payment of the invoice. We also need to pass in the expected amount. We have to parse it to blockchain readable amount. So we're using Ether's util to parse the Ethereum, and we're taking the string out of it. So for this specific request, we're going to use 001 ETH. We also need to pass in the payee and the payer. So these are Ethereum addresses, and you can see here, this would be the wallet address for the person that received the money after the invoice is paid, and this is the wallet address for the person who's paying the invoice. We also need to pass in the timestamp. Here, this will be the signer. So this will be the wallet address of the signer as well as the type, which is Ethereum address. The payment network, which will take in, again, the which payment network we're going to have it in. So Sepolia, Mainnet, Polygon, Matic, whatever we want to use. The payment address, so which is the wallet address that will receive the money. And we can also have a fee address and a fee amount. So by passing in the fee address and the fee amount, we can specify a fee that we can receive as an application. So for example, if someone is paying an invoice through our application, we can take a cut, a 10% cut, for example, when the invoice is paid. If we want to specify that, we need to pass in our fee address and the fee amount. Since now it's the zero address and the zero amount, there will be no fee deducted. In the case of we're using an ERC20 token payment, we need to also pass in the token address. And we have the content data. This is a fully optional and can be customizable to your own use case. Here you can pass in data such as the invoice information if you want, or any payment information. So this is fully up to you. in our use case here, we'll put in hackathon and we set it as request network end of the year hackathon. And now, since we have our context done, we just need to call the create request method and pass in the request parameters that we just created. We need to await for confirmation, and then we can get the request ID. Once we have the request ID, we can start creating the payment. So we would need an RPC provider and a wallet. We need to get the data of the request. We cannot pass in the request itself. In order to make the payment, we need the request data. So we're calling the gate data on request in order to pay it. And then we're passing the data to pay request as well as the signer, and we're waiting for the request to be created properly. I will run this now so you can see how it works. So I will open a terminal. And in my terminal, I'm just going to run this script. And we can see right now that we created a request successfully with this ID, as well as started the payment process for this request. Meanwhile, while we're waiting for the request to happen, I will show you in our tool called Request Scan. And if I paste in the request ID and search, we can see the request information here, the content data that we just wrote, such as request network end of the year hackathon, and the amount, and you can see that it's paid, and we can see the actions that it's been created 30 seconds ago and has been paid 28 seconds ago. So going back to the code, we can also, if you have any questions, by the way, please do. If you have any questions on this code, if anything's confusing, please do ask. We can also get the request data by having a request ID. So we can take in the request ID and go from request ID in the request network instance. And this would allow us to get the request and we can see all the data. And we can also get all of the requests that are linked to a wallet. By using the from identity function, we pass in an object of type and value, the type Ethereum address, and then the wallet address. And by calling this, we can get all of the requests that are linked to a wallet. Earlier, I mentioned that we have an in-memory request, and this in-memory request will allow us to skip the persistence initially and then prioritize the payment. In order to have in-memory request, we can just add skip persistence as true in the request network instance when we create it initially, and everything else would stay the same. The parameters are going to stay the same. Creating the request is going to stay the same. The only difference here is that we cannot use request.getData because the get data uses the subgraph and IPFS information, as I mentioned earlier. And since we're not persisting the request, we cannot do that. Rather, we can use the in-memory request, which has in-memory info, and we use request data. By doing this, we're bypassing the need to fetch the data from the subgraph and IPFS and using the in-memory information directly. Payment of the request would still stay the same. The only necessary step that we need to do later is create a new request network instance with the same information as the Gnosis gateway. And we just cannot do the skip persistence again, because if we use the skip persistence, we cannot persist our request. With the new request network instance, with the request network, the new request network instance, we can call persist request and pass in the new request that we created. Not the request data, but we need to pass in the actual request. And if I run the terminal again, and run the script, we would see that the request was created successfully and we started the payment, but we started it much faster than we would have started it if we did it initially. And let's copy this address, and if we search for it again in the request scan, it would show us not found as it is not persisted yet. Now, since the payment is done successfully, we will wait for a couple of seconds, and then we can try searching again and seeing if it's persisted. And right here, we can see that our request, we can get the request data on request scan and it's paid with the same amount. But the only difference is that the payment action is earlier than the creation action. So here the payment is prioritized instead of the creation, and then the creation comes after. Are there any questions so far about the use of the SDK itself? Okay, I'm going to assume that that's a no. And we can move on to show you the other tooling that I talked about earlier, such as the request injector. So the way the request injector works, it's a CLI tool. So if we write npx request injector and run it, in the root of our project, we can see that it will scan the project first, and then prompt us to select which functions we want to inject. We have multiple functions called prepare request, create request, pay, persist in memory request, get request by ID, and get request by wallet address. We can choose whichever function that we want to include in our project. We can choose between TypeScript and JavaScript. And if we choose JavaScript, we can choose between ECMAScript or CommonJS. And we need to choose the path we want to inject our code into. I'm in the workshop directory, so I'm going to do that. And it will inject the code we need, and then it will install all the necessary packages automatically. So if I go back to my code and open up my code editor, we can see the request network folder here. And if I open it, we can see that we have practically the same functionality that I mentioned earlier, such as prepare request, where we create an object for creation of the request, creating the request by starting an instance and then calling the create request method, paying for the request, as well as persisting the request, persisting the in-memory request. So the difference between using the SDK directly and the injector is that the injector would give you all of the code that I went through earlier here automatically by just running the tool. And this will help you by injecting the code so you don't have to write it yourself again. And you will also have the code customizable in your code base. So you can easily go through the code, edit it to match what do you need exactly, and then use it. So this gets you from point A to B much faster than going through the SDK and writing the code yourself. So now with this done, I want to go back and show you the templates that we have. So starting with the request invoicing, which is an invoice and application template. It's fully open source. You can build upon it. It's built in web components in Svelte. And this allows you to create, retrieve, and pay requests. All of these information, by the way, can be found in our docs. All the code that I showed earlier, such as for the creating of the request, can be found here in the browser and in a backend node script, as well as the templates that I'm showing right now. For example, the invoicing templates, the checkout templates, all the components that are linked to them, as well as the request injector itself. So if you need any help, or if you think you're going to miss this information, you won't. Everything is in the docs. So the way request invoicing work, it's built on top of Svelte as a web component, and it allows you to create and retrieve and pay the invoices. And we have here a small demo for you that we can start. And this is how our request invoicing looks like. We have a dashboard component that would, as long as the wallet is connected, show you all of the requests, and you can sort them by the request you have to pay and the request you have to get paid. And we also have a create an invoice component that would have the fields on the left, and you can see the invoice automatically match and update to the right. And all you need to do is fill in the information here, such as hacker with the hacker email, the client information, the wallet they need to pay with, and all of the billing information, such as the company name, the email, the address, and then you select a payment chain. For the demo, we're going to select Sepolia, for example, but you can select any of these available chains, as well as any currency you would like to use. In our case here, we're doing FAU, and the address which you would like to get paid into, the item, for example, hackathon first place for 1,000 FAU, and the due date of the invoice. All of this functionality is built into the web components, so you do not need to build any of these functionality yourself. All you need to do is install the web component itself, and you can get this functionality. I will show the integration in a bit as well. So once we click create request, we can see that we're persisting the data to IPFS, and then we can go to persist the data on chain. And once it's confirmed, we can go back to our dashboard where we can see the new invoice has been created. If we switch the wallet to the wallet that we need to pay with, we can also see that they have the invoice that they have to pay showing for them automatically, and we can see the view of the invoice itself. And since this is an ERC20 invoice, they will need to approve the transfer of the tokens if they haven't approved before, and then they would start the payment. They will need to start the transfer and confirm it, and then it will load and complete the payment. And once the payment is detected, we can see that the invoice shows as paid now. So this is the request invoicing and its demo. And we also have the request checkout. The request checkout is very similar to the invoicing application. It is also open source and built on Svelte and allows for the creation of the in-memory request. The main difference is the flow of the requests. So instead of creating an invoice initially and then waiting for a user to pay it, this checkout would be very fitting for an e-commerce website, for example, or a website that requires the payment first and then would generate a receipt afterwards. We have a demo here for a ticketing app where we can select which ticket for the event we want to go to. We would pay in USD, and we will pass in the amount in USD, and we will pay with either, for example, Ethereum or USDC or any currency that the seller would like to accept. So the main thing here is that instead of waiting for the creation of the request, we will jump into the payment directly. And once the payment is finished processing, the request is then persisted. We also have Request Scan, which is an open source tool that allows you to go through all of the requests, and you can see the request details as well as the payments. This is the tool that I was showing you earlier in order to see the details of the request. And now we need to go to the integration itself. So in order to integrate the web components, such as the invoicing components, for example, all we need to do is install Request Network's invoicing dashboard, and then we import it. For example, this is an Next.js project. So once we import it as Request Network slash invoicing dashboard slash React, and all we need to do is put in the web component itself. It takes in a few properties such as config, which is it takes in, for example, the customization colors, the builder ID, which is the ID that is unique to you, so we can identify whose requests are who. It takes in the dashboard link, so when a request is created, we would know where to forward back, as well as the logo, for example. It also takes in currencies. So these are a list of custom currencies that you can add into the already existing default currency list that the web component has. It also takes in the request network instance, which is the same instance that we showed earlier when we created it in our SDK, and WAGMI config, since the web components are compatible with any wallet connection that is WAGMI compatible, such as RainbowKit, Wallet Connect, or any WAGMI compatible config. And once you save, you would be able to see the same dashboard that we showed earlier. And the same thing for the other create invoice form. You'd pass in the same properties and you would be able to use it. The invoicing are two components that are pretty independent, so you do not need to use both at the same time. All you need is, if you need a form to create invoices, you can just use create invoice form and that will be sufficient. Or if you just need a dashboard, the invoicing dashboard would be enough. Similarly, we also have the payment widget, which is the payment widget that I showed earlier. All it takes in is the amount in USD, which is the total amount that the payment happens. And then at the time of payment, we have a conversion that will give us the equivalent of whatever currency that the user wants to pay in. It also takes in the seller address, which is the wallet address that will receive the payment once the payment is done. It takes in the builder ID, which is again a unique identifier, but this is very optional. It also takes in the supported currency, and we have a big list of currencies that are supported. And these currencies are the list of currencies that the seller would like to accept. So for example, East Sepolia and USDC and USDC Sepolia, meaning the amount is denominated in USD, but you as a buyer can choose to pay with any one of these three currencies. So only these three, amount in USD, seller address, and supported currencies, are required, but we have much more optional fields such as the builder ID, as I mentioned here, on payment success, which is an event that allows you to do actions whenever a request is created a request is created successfully, and you can also get the request here. We also have on error. It's very similar. It passes in the error that happened, and you can handle your error however you want. We can also pass in the fee address and fee amount to take in a fee if necessary. And we have a bunch more that you can use, such as buyer info, seller info, enable PDF receipts, and yeah. That would be it for the beginner workshop. Tomorrow we would have another workshop. We will go deeper into the more topics. And now we're open to a Q&A if you have any questions about the integration itself, or if you have questions about the hackathon overall. I saw the question about you're beginner to Web3 and participate in the hackathon, but your mind is blank on what you want to build. You can build practically anything that deals with payments or invoices, such as an e-commerce website, an invoicing website. You can also read the data, like the financial data that a wallet has, and you can do an accounting website and have more websites that would read and generate, for example, graphics on, as well as analytics on the financial data. If you want, you can write on Discord and we would help you if you want. Can we send an invoice from a smart contract to a user address? Uh, can you elaborate a bit more? I did not understand. What do you mean? Do you mean, can you do the integration where from your smart contract you would send the request? If that's the case, where you meant if you want to create the invoice directly from your own smart contract, I don't think that would be possible, because our own smart contract is the one that is taking care of the storage of the data on the IPFS, and then the subgraph would detect that and index that storage. Can we build mobile applications? It is possible with Expo. We do have in our documentations uh, a mobile integration, uh, with Expo that would walk you through all of the necessary steps to integrate Request Network with Expo directly and build with Expo. But I do not think that would uh, allow you to use the web components that I mentioned earlier. Unfortunately, currently we do not have Flutter support, but that would be something that we might consider. Um, but unfortunately, at this moment, there is only Expo support. Yes, we are open source. So if you would like to have Flutter support, it is very possible to open an issue and a PR on Request Network. So if you go to GitHub Request Network, you can go to our project and discussion and open up an issue if necessary, and you can contribute to the Flutter as well. Um, I don't think building Flutter support would be considered as a hackathon project. But if you get it to work on Flutter and then build an app on top of it, I would think that would be acceptable. You should ask this question on Discord and we would get back to you with all the necessary information about that. Okay, if we don't have any further questions, I think we can end it here. Thank you very much for joining our workshop. Hope you enjoyed it and learned how to get started with Request Network. Tomorrow, we'll also have another workshop at the same time for more advanced topics. And yeah, thank you very much. Can you build an application that is micro SaaS? That depends on the use case of the micro SaaS. As long as you use Request Network to the same way that we have the guidelines in the hackathon, that should be acceptable, yes. Okay, thank you very much. See you guys tomorrow. My favorite idea. I don't really have a favorite idea currently, but we do have a lot of ways that you can integrate Request Network, as I mentioned earlier. We do have a new tool, as I mentioned earlier, the single request forwarder. I would love to see projects that would use that and try to integrate that into their workflows. Yeah, that would be cool to see. Okay, thank you guys. Please don't forget to join the Discord if you have any questions. We also have office hours and we can help you there.